We've been talking about equalities, which just says this side of an equation is the same as that side of an equation. So if I were going to do a little picture, I could say, well, an equation looks like this. Balanced. What we're talking about now, let's try again. What we're talking about now is like this. So my little diagram says the right-hand side of that seesaw is bigger or heavier than the left-hand side. Inequality. It's not balanced. And some inequalities can be a combination of those two. You could say, well, it's either greater than or equal to. It obviously can't be both at the same time. But we've got 4 different flavors here. Just plain old linear. We've got 3-part, quadratic, and then rational. We're going to try and cover those first 3 today. Here's a reminder. Please copy this down. Just make sure you got it. Do not write this down. Just take a look at it. Notice a couple of things. Over here on the left is what it would look like that first one, x such that x is greater than a. Don't let this freak you out. What does it mean? All the numbers bigger than a. What's a graph look like? Notice, though, that they are using a parenthesis here, meaning that it can't be equal to a. And then it goes to the right. We're looking at the top line here. But then here's what I really am interested in, this interval notation. Notice the parenthesis by the a means it can get as close to a as you want, but it can't touch it. It goes out this way forever to the right. It can get as close to infinity as you want, but it can never touch it. Well, we can't touch infinity anyway. It's just a concept. Infinity is not a number. And so we look through these and really pay attention to the graph and the interval notation out there. Like the 1, 2, 3, fourth one down. Notice it's got b, but there's a bracket there, meaning what? It can equal b. And the bracket is in the interval notation out there. It says, yeah, it can get all the way to b and actually equal b. So we're using parentheses when it can't equal something and brackets when it can. And then here's the corresponding graphs. Look at the one next to last. It's saying it could be as close to a as you want and then everything smaller than that. Or it could be as close to b as you want and everything bigger than that. Look at the interval notation. I can't just say it goes from negative infinity to positive infinity, because it doesn't. We've got that gap in between. So you have to use this U, stands for union, meaning either this side or that side. Can't be both. And that's a disjoint, meaning they're not connected. There's a gap in between. All right, look at that in the book. Just go over it. Make sure you're understanding what they're talking about. First kind we're looking at here is linear inequalities. And like the notes say, you're going to solve it just like you do an equation. I want to get all my x's on one side and everything else on the other side, just like an equation. So the first thing I'm going to do is subtract 7 from both sides. And notice I didn't flip that less than sign, because I didn't multiply or divide by a negative number. Next thing I want to do is divide both sides by -2. But notice I'm dividing by a negative number, so I've got to flip this thing around to be greater than. So what would that look like on a number line? Well, I'd have my negative 6, and it'd be an open dot, right? The way we normally graph things. And it would be all this stuff to the right, negative 6.
Would that be a positive 6?
It would be a positive 6.
Mr. Diamond, read your attendance.
It's right there on the desk. Well, thanks for getting it. Positive 6. Thank you for catching that. So I've got my number line again. I've got positive 6, open dot. Puts everything out there. Now, what's it look like in interval notation? Here's what you do. You say, what's the smallest it can be? What's the smallest x can be? 6. But can it reach 6? Nope, so I put a parenthesis. What's the biggest it can be? Infinity. Can't reach it, so there's interval notation. I know you've seen it before, but I'm just trying to make sure everybody's got this because we're going to be using that notation quite a bit. Everybody good with this one? Well, let's take a look at another one. A little more complicated. So I've got my choice. I could either bring the 2x over to the left or the 4x over to the right. I'm going to take the 4x to the right. So I'm going to add 4x to both sides. So over here I've got 3 greater than or equal to 6x plus 8. Then I'm going to move the 8 to the left-hand side, so I subtract 8 from both sides. And then divide by 6. Now I'm dividing by a positive number, so I don't flip my sign. And I get that. So number line wise, here's my negative 5, 6. Can it equal that? Yeah, so I put a closed dot from graphing it. And it says greater than or equal to, so I know it's everything this direction. Interval notation, I ask myself, what's the smallest that x can be? I'm getting negative 5, 6. Can it be equal to 5, 6? Yeah, so I put a bracket. What's the biggest it can be? And I put a parenthesis. So that's about as hard as that linear type gets. You just have to be careful with the brackets and the parenthesis. And y'all, when you're doing the homework online, if you put a parenthesis where it should be a bracket, it'll count it wrong. And you'll look at it and go, I got this right. Don't be tricked. It's a computer grading it. So those parentheses and brackets actually mean something different. So make sure you get those right. Well, I'm just messing this up all over the place.
Maybe they just need to stop everything.
Good suggestion. I should have written it like this, right? That's the way we would say it. Okay, let me try again. So I've got my negative 5, 6. I've discovered that when I'm talking and doing a problem, both of those don't fit in my mind at the same time sometimes. So it could be equal here. It's everything going back this way. So now what's the smallest it can be? Thanks for catching that. Negative infinity. and it can come all the way up to negative 5, 6, and can equal that. Okay. Give me enough tries and I can get it. Let's try another one. Three-part inequalities. And the trick is to isolate the x in the middle. Notice I've got 3 different parts to this thing. Now with equations, we're used to saying whatever you do to one side, you got to do to the other side. Here, with this 3-part inequality, whatever I do to one part, I've got to do to all 3 parts. So I want to get rid of that negative 8 in the middle. So I'm going to add 8 to all 3 parts. So that gives me 9 less than or equal to 6x less than 12. Okay, I still want to isolate just plain old x in the middle. So I divide everything by 6. And over here on the left, I've got 3 halves. Here I've got just x, which is what I wanted. And here I've got 2. So graphing-wise, here's 3 halves. Can it equal 3 halves? Yeah. Here's my 2. It cannot equal 2, though. So it's all of this stuff. That'd be the graph. Interval notation. What's the smallest it can be? And it can equal 3 halves because that's what it says right there, less than or equal to. So I put a bracket. It can get up to 2 but not reaching 2, so I put a parenthesis. Be extra careful with the parentheses and the brackets. Question, anybody? Not so bad. These are not so bad. Let's try this one. So I'm going to multiply all 3 parts here by 3. So on the left, I've got negative 15. This would just leave x minus 3 here. And what, 3? Then I'm going to add 3 to all 3 parts. It's going to be 12 negative. I've got it. All right, so number line wise, I've got negative 12. It can equal negative 12. I've got my 6. It can equal 6. And all of this in between. Interval notation wise, the smallest it can be is negative 12. Can it equal it? Yeah. Biggest it can be is 6. Can it equal it? Yeah. And this is called a closed interval. If we were in geometry, we'd be calling that a line segment. Let's pause for a second and see if anybody has a question. Just look at it with me. Now we're talking about quadratic inequalities. Now, if we're talking quadratics, we're thinking usually 2 solutions, right? But we're talking about inequalities, so that means an infinite number of solutions. So where does the 2 come in? Show you in just a second. So step 1, treat the inequality like it's an equation. That's this part. For a minute, treat it like it's an equation and solve it. This is in the book. Don't write it down. Can't use notes on tests anyway. Those are for studying only. Then we're going to determine these intervals based on the solution. That's easier to see than it is to explain. And then last, we're going to test to see which of those intervals make our original thing true. Now, that doesn't mean anything to you at the moment. So 3 steps. Going to treat it as an equation and solve it. We're going to divide the number line into 3 parts and see which of those 3 parts make our original inequality true. I'll show you what I mean. This thing. Jot it down, and then let's solve it. Step 1, treat it like an equation. Okay. X squared minus 2x minus 15 equals 0. Now, I know I'm not dealing with an equation, but I'm going to treat it like one. Then I'm going to solve it. I'm going to get 2 values for x. So, if I use the AC method, when I multiply the 2 numbers together, I get negative 15. When I add them, I get negative 2. What values could I have that will do that?
Negative 5 and 3.
Negative 5 and positive 3?
Yes,
All right, thank you. So I've got x squared plus 3x minus 5x minus 15 equals 0. Now what I've got in blue, we're treating it like an equation. It's really not. So I can pull, from my first 2 terms, I can pull out an x. So I get x plus 3. For my second 2 terms, I can pull out a negative 5. I combine the 2 things that are multiplied times our common stuff. So I got x minus 5. At this point, we've got the 0 factor property, which tells me I can set each of those to 0. So there's one of our points that we're going to look at. It'll make more sense in just a second. Then x plus 3 equals 0, so x equals minus 3. There's our other one. So we've done step 1. Step 2 says take the number line and divide it into 3 chunks. Well, how do I know where the chunks start and begin? Those 2 numbers right there, the 5 and the negative 3. So here's my number line. Negative 3. Now, I'm going back up to the top here. Look right here. This thing right here says less than or equal to. So I could color in my negative 3. Less than or equal to. So I could color in my 5. So I've divided the number line into 3 pieces. Everything from negative 3 back to negative infinity, in between negative 3 and 5, and anything 5 or bigger. That's step 2. That's why I said it's easier to just show you than it is to explain it. Step 3. I want to see which of those chunks make our original thing up there true. So what I'm going to do, I'm going to pick a value smaller than negative 3. And you get to pick the value. Make it something easy. It could be a fractional number. It could be negative 20.6582. Don't do that. Pick an easy number. What do y'all want?
I'll just use that number since it's also equal to.
Stay away from the endpoints if you can.
I
Negative 5 I'm hearing. So I'm going back up and plugging it into my original inequality. So I've got negative 5 squared minus 2 times negative 5 minus 15. Is that, now see we're asking, is that less than or equal to 0? So here I've got 25 plus 10 minus 15. Is that less than or equal to 0? Got 35 take away 15, that's 20. No. So what do I know about all these numbers out here to the left of negative 3? They don't make our original inequality true. All I had to do is pick one out there and test it. That's what we just did. So let's try in between 3 and 5. So I'm going to pick a number between negative 3 and 5. Pick something easy. What's the easiest thing you could pick? 0. Right? Because if I plug 0 in, the x squared term is going to drop out. The negative 2x term is going to drop out. That's going to leave me negative 15. Is that less than or equal to 0? Yeah. So if you want to write it out, you'd be doing this, right? These two go away. 0 is the ideal number to pick there. So I know that that's true. Then I want to pick something bigger than 5. So we're testing each of these 3 chunks. So 6. So we've got 6 squared minus 2 times 6 minus 15. Is that less than or equal to 0? 36, take away 12, take away 15. So I've got, on the left, I've got 36, take away 27. That's 9. True or false? False. So now then what I'm really saying is only these values in between these two numbers make our original inequality true. How do I write that in interval notation? Same way that I always have. I'm saying what's the smallest x could be? Negative 3. Can it equal negative 3? Yeah. Bracket. Biggest it could be. 5. Can it equal 5? Yeah. So these quadratic inequalities, that's the steps. You solve it as though it were an equation. You divide the interval, the number line into 3 different intervals, and then you test each interval to see if that interval makes your inequality true. Now notice that turned out to be another closed interval there. Any number in between negative 3 and 5 will make our original thing true. Quite a bit different from an equation. Let's do another one. Step 1. Treat it as though it were an equation. AC method. When I multiply these two things together, I'm getting 10. When I add them, I'm getting negative 7. Negative 5, negative 2. Okay. Thank you, sir. So I've got x squared minus 5x minus 2x plus 10 equals 0. So I can pull out an x, so I get x get to there, I start combining some things here. We're down to the 0 factor property. I can set each of those to 0 and solve for my x values. There's step one. If that had been an equation, those would be my two possible solutions. But we're talking about an inequality. So step two is I take my number line, divide it into chunks. Now then, if you look at the original inequality, it says just greater than. So my 2 and 5 have to be open dots. I've divided the number line into 3 pieces. Now we start checking. So pick a number less than 2. 0 works. So I've got 0 squared. These two terms are just going to drop out. So those just go away. That's 0. Is 10 greater than 0? Yeah. So this one works. I pick a value between 2 and 5. Gracie, what you want?
Between what?
2 and 5.
3.
That works. So I've got 3 squared minus 7 times 3 plus 10. Is that greater than 0? So I've got 9 minus 21 plus 10 greater than 0. So on the left I've got 19 take away 21. And the answer is no. That one doesn't work. I go out to something bigger than 5. 6. So 6 squared minus 7 times 6 plus 10. Is that greater than 0? So 36 minus 42 plus 10. On the left I've got 46, take away 42. 4, is that greater than 0? Yeah. So now I've got one of those weird kind, the disjoint situation. So what's the smallest? So in other words, if I'm going to color it in, I'm getting all this stuff out here, I'm getting all this stuff here. Here's the trick. What's the smallest it can be? Yes, ma'am? Negative infinity. Can't reach it, so I put a parenthesis. But now I can't just say what's the biggest it can be, because that'd be positive infinity. I can't write this. Why? Because that implies all the numbers in between. Well, what's the biggest that left-hand chunk can be? 2. Can it reach it? Nope. So I put my union symbol, and then I'll pick up on the right, and so 5 is the smallest the right-hand chunk can be. Can't reach it, so I put a parenthesis, and then positive infinity. So there's the graph of the solution and the interval notation. Now notice, it's going out separate directions. Disjoint. Something to look at. Look at this symbol right here. It was greater than. When it was greater than, we got a disjoint situation where it's got a gap in the middle. Look at the one before it. Less than. And we had a closed interval. Keep that in mind because it'll help you check these things. Let's do another one. So we're going to, first thing I do is multiply everything by -1. So if I multiply everything by -1, what do I have? I've got x squared plus 4x plus 6 is less than or equal to 3. But I didn't do something. What did I miss on that? Yeah, I can't forget that. So this sign flips around. This symbol flips around. Okay, so then I'm going to treat that as though it were an equation. So I've got x squared plus 4x plus 6 is equal to 3. I subtract 3 from both sides. Because I want it in standard form to be able to solve it. Can you all look at that one and tell what the factors are? If not, we can do AC method. So I multiply two numbers together, I get 3. I add them together, I get 4.
3 and 1.
Let's go with that. So I've got x squared plus x plus 3x plus 3 equals 0. I've got, pulling an x out, I've got x plus 1. Pulling a 3 out, I've got 3 times x plus 1. X plus 3 times x plus 1. Zero factor property. So I can set each of those to 0. So there are two, if this were an equation, our two potential solutions. Number line. I've got -1, -3. Can these be equal? Go back to your original thing. Is there an equal sign there? Less than or equal. So yeah. So I've got -1 and I've got -3. Then I start testing. What's a number smaller than -3? Okay, so I put negative. I'm going back to my original now, y'all. So I've got -4 squared minus 4 times -4 minus 6. Is that less than or equal to -3? So -4 squared is 16, but then the minus in front says -16. -4 times -4, 16, minus 6. Is that less than or equal to -3? Well, look what the 16s do. They cancel. Is -6 less than -3? Yeah, so that one checks. Now I need a number between -3 and -1. That works. So I've got, going back to my original, -2 squared minus 4 times -2 minus 6. Is that less than or equal to -3? So -2 times -2 is 4. The minus sign in front makes that -4. -4 times -2 is 8. Did I mess up someplace? Oh, no, I didn't. Just look weird for a second. On the left, I've got minus 10 plus 8, so that's -2. And the answer is no. -2 is not less than or equal to -3, so that one doesn't work. Let's try one more here. So let me shrink that down just a little bit so we got some room. Okay, so pick a number. Oh, here's an easy one. Bigger than -1. 0. All right, so if I wanted to write it out, I would have minus 0 squared minus 4 times 0 minus 6 less than or equal to -3. Those go away. Is -6 less than -3? Yeah. So we've got another disjoint one. So I want everything out this way, everything this way. So what's the smallest that x can be? Yep. And then the left-hand chunk, the biggest it can be is -3, but it can reach that. Union. -1, which it can reach infinity.
I have a question.
Yes, ma'am.
So I did it, but to like check the answers, I used the equation we got to, so x squared plus 4x plus 3 equals 0.
Uh-huh.
I used that to check it, and it turned out to be the same answer. Will that work every time?
My first thought is yes. Excuse me. Okay, got one more, y'all. Good question, Bailey. This one. Believe it or not, there's some in the homework like this. So we treat it as though it were an equation and solve. So x equals plus or minus the square root of 9, which is just plus or minus 3. So we've got our 2 points. It's still quadratic. We're still getting 2 possible points. So now what? Number line. I've got my -3. Can it equal -3? No. Because my original inequality said just less than. All right, we try something less than -3. So I've got is -4 squared less than 9. Well, -4 times -4, 16. And the answer is no. All right, we try something between -3 and 3. What's our big choice? 0, thank you. So is 0 squared less than 9? Ding. And then we try something bigger than 3. 4 works. Answer's no. So we're wanting all of the stuff that I'm coloring in. What's the smallest x could be? -3. Can it reach it? No. 3. Can it reach it? No. So there's our answer. That's it for me today, y'all.